So, main thing to think about are fungi are its own kingdom. And so, animals are a kingdom, and plants have a kingdom, and fungi have their own kingdom. And so, a lot of people think they're like plants, but they're really not. They function a little more like animals actually than like plants. I mean, there's people will argue with you whether they have a conscience and all that kind of stuff, but the mushrooms that we grow, they digest substrate, they release enzymes kind of like your stomach does. They breathe in oxygen, they release CO2. They don't have lungs, but the functioning that is happening with these organisms is more similar to animals than to plants, than to most plants. But the mushrooms we grow, they're called saprotrophic mushrooms, which means that they're like a digester mushroom. And we feed them mostly sawdust, and it's a byproduct from the timber industry. Most mushroom farmers are using industrial byproducts, whether it's from farms or horse manure in Pennsylvania, which is amazing for a lot of mushroom growers. But we found that sawdust from the timber industry needed dealt with. It still goes to landfill, and it's a great product for these kinds of mushrooms. That's what these mushrooms grow on naturally anyway. And so we source all of this byproduct. It's hydrated and sterilized and then seeded. It's inoculation is technically the term, but you put a little bit of the mycelium, which is the living organism, into each of these substrate blocks. And then it grows out and it releases enzymes and breaks down that substrate. Eventually, when it's done with its food, then it fruits out the mushrooms, and that's what people are eating. The fruit of the mushroom is kind of like an apple off an apple tree. So when you buy a mushroom on the shelf, it's a part of the reproductive cycle. It's not actually the living organism. The living organism is in the mycelium, and that's a fibrous sort of net that exists everywhere. It's under the ground. There's different kinds of it. The type that we grow are again these saprotrophic mushrooms, but there's fungi that have relationships with trees, mycorrhizal relationships. There's other types of fungi that have different relationships with their environment, but the mycelium network exists all over the place. And I'm sure you can go down a wormhole just talking about that, but that's the living thing that we're trying to cultivate that then eventually fruits in our spaces. And so what we figured out a bunch of stuff, but the technology itself really is extremely good at running the fruiting cycle of the mycelium. And so inside of each of those mini farms, as well as our large facilities, they capture tons of data and then push them to our own servers. We're running our own analysis of what's going on in that space. And we're trying to not only replicate climates that these mushrooms are from, but modify those climates so they're even better for these mushrooms in whatever environment that they're in. And that's unfortunately kind of complicated. So the mushrooms generally want cool temperatures, high humidity, and high airflow. They release CO2, but they don't really like being around too much CO2. And so all those things individually are not that complicated, but once you're trying to do them together, especially when you're trying to be efficient with your use of resources like we are, it's way too complicated. And so we had to develop our own ways of doing it. And we're not the only mushroom farm out there. Obviously there's a whole industry, but we couldn't find any control system out there doing exactly what we wanted. And so I started building it, but we have a whole engineering team now that's built the whole entire thing. And now we have granted patents on it as well. But it's the same system that's applied to our larger facilities, the macro farms, just in a larger footprint. But all of that data gets pushed into this large database that we're collecting on all the varieties that we grow. And so it just makes us smarter and smarter and grow better and better as we continue to scale.